Alright, you guys, I'm going to do a bunch of these problems, and I want you to do the ones I don't do. I plan on doing this one, these three, ABC, and GHI. They're really not bad. The whole premise is that if you have a log, you can bring the exponent down to the base rule, and that's the fourth rule we studied. And here, we're going to go through with this. Look, if I was going to solve this, what I want to do is I want to solve for this E value here. So I'm going to start by dividing by 275, dividing by 275. I'm going to write this whole thing. I've got e to the 0.06x equals whatever 1,000 divided by 275 is. Now, you are allowed to log both sides, or natural log. In general, if you see an e, right, because natural log has a base of e, it makes this a little easier, right? You can make both sides of the equation a natural log. So, once that's done, you're allowed to bring this exponent to the front. So I can say 0.06x, right, times the natural log of e equals the natural log of 1,000 over 275. Well, natural log of e is really log base e of e. That's what it is. This really says e to what power is e? Well, the answer is 1. So this cancels out. And what you get is you get 0.06x equals the natural log of 1,000 divided by 275. And then we want to solve for x, so we divide by 0.06. We divide all that by 0.06, and we'll get our answer. Right? X is equal to. So, let's go ahead and stick that in. Hopefully we can see this. The very first thing I'm going to do is I'm going to say the natural log of 1,000 divided by 275. And I'm going to hit enter. And then I'm going to divide that number, right, by 0.06. And I get about 21.52. So I should use squiggly lines. 21.52. My son wants to know if a calculator is cheating in class, and I'm going to have to let him know not with logarithms, because you can't do them in your head. So we're going to do the same thing for these three. So here we go. Once again, the exponent's at the high, right? So we're going to natural log both sides and bring the x to the front. Now, honestly, I could have logged both sides of this because my base wasn't e or 10. All right, but with 12, ln's a little easier to write than log. Not much, one less letter. Then I divide both sides by the natural log of 12, the natural log of 12, and I get x equals. Once again, look, bringing my calculator back. I'm going to say the natural log of 30 divided by the natural log of 12, and I get about 1.36 or 1.37. So approximately 1.37. Alright, we got 5 more to go on this side, 1 on the other. This one's going to be beautifully easy. Again, anytime your base is e, the natural log is the way to go. And then you bring the exponent to the front. The natural log of e is just 1. And then we got x equals whatever the natural log of 97 is. Alright. So here we go, natural log of 97. And you get about 4.57. I should be using squiggly lines, right? Approximately 4.57. Done. So now this one right here has a 10 base. So again, in most instances it doesn't matter, but if the base is 10, log's the best way to go. So if I log 10, I'm going to even put the base in there, equals log of 68. Alright, this log base 10 of 10 is 1, and x times 1 is just x, so it goes away. And my answer is going to be whatever the log of 68 is. So log of 68, which is about 1.83. My son is still in the room. He's waiting for me to tell him. He wants me to make him some breakfast, but he's going to have to wait 4 more problems. Alright, so I'm going to subtract 5. I'll be there soon, buddy. And I have 2e to the x minus 1 equals 75 divide by 2. We want to get that e by itself, right? Before we, what is that? That's, what, 37.5 is probably the way to go. And then I want to natural log both sides. Alright? And you get these cancel out, and the x minus 1 comes to the front. And we get the natural log of 37.5. And then I add 1 to both sides, and I'm going to get x equals whatever that is. So here I go. Natural log of 37.5, and my parentheses, I think we said plus 1. I hope we did anyway. And it looks like about 4.62. Alright, here's a situation, it doesn't matter. So, minus 20, minus 20. And I get 6 to the 3x equals 12. And now I've got a log or natural log. Again, I'm only choosing natural log because it's easier to write. And then 3x is going to come out front. Now in this situation, I'm going to have to divide by 2 things. I'm going to have to divide by 3 and the natural log of 6. So I divide 12 by 3 times the natural log of 6. And that's going to give me x. Let's see if we can plug this all in. So here we go. So we've got the natural log of 12, end parentheses, divided by begin parentheses, natural log of 6, end parentheses, times 3, end parentheses. And we get about 0.46, approximately. Again, I'm not using squiggly lines, 0.46. Alright, I'm going to do one more on this side, and then we'll hit the other side. For this guy, we add 12. Alright. And I get 2 to the x minus 3 equals, what is that, 85? And again, it doesn't really matter. I can natural log or log. It's just easier to write ln. So I've got x minus 3 times the natural log of 2, alright, equals the natural log of 85. We divide by the natural log of 2. And then we got x minus 3 equals, again, the natural log of 85. You might as well just save it to the end and put it all in, right? Natural log of 2. And then we're going to add 3. Right? So we got this divided by this plus 3. So I'm going to do it just in order. Natural log of 85, enter. Divided by the natural log of 2 plus 3. So we got 9.41 approximately. So, one more side, and let's take a look at this. Alright, real world problem, and we should be able to do this. Let's see how quick we can, so it doesn't mess up when I log it. I only can go a few more minutes and still. So here we go. Write an exponential equation to model each growth. A local government projects that a town will grow at a continuous rate of 19%. So the growth rate is going to be 1.19 per year. That's not the growth. But anyway, 1.19. How long will it take the pound's population to be 4 times? There's a lot of ways you could do that. You could make up an arbitrary number and say, hey, if it starts off at 100 and grows at 1.19 to the x, how long does it take to get to 400? Right? Or you could say, how long does 1.19 to the x take to equal a ratio of 4? Both of these would be the same, right? If I divided by 100 here and here, I'd get 4 equals 1.19. So you don't have to make up arbitrary numbers, but if it makes it easier for you, you can. So natural log, and we get x times the natural log of 1.19 equals the natural log of 4, and we get x equals whatever this is divided by the natural log of 1.19. So natural log of 4 divided by natural log of 1.19, and no clue what I did wrong there. Looks like about 7.87 years. I might have said that wrong. I did, 97 years. Alright, so this is very similar. I'm not going to do this one. I'm going to come down here and do this one. Alright, Greg bought gold for $9,000. And okay, if we're going to say the coin, there's a mistype there, increases at a constant rate of this. How many years to reach? Oh my goodness. Alright, so my start rate is 9,000. I grow at 1.0179. Remember, the decimal has to move over twice per year. It is going to take a really long time to reach this level. A really long time. But let's solve it. We're going to have 9,000 divided by 9,000. We get 1.0179 to the x equals, I'm going to go ahead and estimate this because it's going to, writing the decimals about as hard as writing math. So 17978.02, doing it on my calculator right now, divided by 9000, and is approximately this, 1.9975577.8ish. And I'm just doing that because it's just as easy to write as that. We're going to natural log both sides, and the x comes out front, natural log of 1.0179, and this equals a natural log of 1.9975577.8, and then we divide, oh, let me make sure this is on the page, sorry you guys. We divide by the natural log of 1.0179, and I think this is going to be the easiest thing you've done yet. 1.0179, and I'm going to go ahead and put that in my calculator and see what I get. Divided by, natural log of that answer divided by the natural log of 0179. Oh, I'm going to go about 39 years. Alright. And there it is. There's one video, about 12 minutes long. Almost reached my max, but we're good. Talk to you guys on, well, if it's 2019, Monday.